So we have covered uh, quite a significant amount on transformers. Only one small topic, but a vital important topic which we should discuss is the phasor diagram representing various voltages and currents for a transformer. Okay, so let us discuss that. Okay. Before we draw the phasor diagram, before that, let us draw the equivalent circuit for a transformer. And you know that the equivalent circuit can be drawn in different ways. I mean, there are different equivalent circuits which are approximately equivalent to each other. Now, you will possibly notice that I have drawn very less number of turns for this inductor and this resistance, whereas there are many turns for this inductor and this resistance. This is just to indicate that these two are of much larger value. This inductor and this resistance has much larger value compared to this resistance, inductance, and this resistance, inductance. Okay, and then these impedances together with an ideal transformer that makes the equivalent circuit of a practical transformer. So this is ideal transformer. Suppose N1 is to N2 is the turns ratio. And then this entire thing represents an practical transformer, actual transformer. Now, normally we know the supply voltage, okay, that may be given to us. Call this V1. This is known, and on the other side we have a load. The load value may also be known to us. And all other parameters like this resistance, call it R1, X1, R2, let me call it R2 prime, X2 prime, this is R0, Xm. These values are also known. So everything is known. Voltage V1 given, this impedance or load Z given. Now, what are the unknown quantities? That those are, yeah, one thing is missing here, the dots, otherwise this is incomplete. Now the quantities which are unknown are this current I1, phasor, this is also phasor, okay, then the secondary current I2, and all other currents and voltages. For example, this may be IR0, this may be IXM. All these blue quantities are unknowns, and we have to draw a diagram, phasor diagram, representing the relationship between all these voltages and currents. Now, where to start our diagram from? I mean, you may be tempted to start the diagram from V1 as the reference, because V1 is the normally the known quantity, given quantity, and all other quantities like I1, I2, and here the voltage V2, all these are derived or decided from V1. So it may seem normal to start from V1. However, if we do that, then it may be slightly difficult to draw the phasor diagram. Rather, it may be easier if I start from V2. Okay, so while drawing a complicated phasor diagram, you always can decide which quantity you want to take as your starting point, your reference phasor, and then the drawing will be simpler. So I will start with V2, but note that V2 is not known a priori. But still, I don't know, but still let me start with V2, and suppose V2 is here. I don't know how long is this V2 or what is the phase angle, but still, suppose this is V2. And if V2 is known, then since Z is known, I can calculate I2. Okay, so let me write here, I2 will be V2 by Z. So if V2 is known, you can calculate how much is I2. Suppose that is here. Okay, so I'm assuming this Z to be of this form, angle theta is positive, so therefore I2 will be lagging the voltage V2. Okay, next what can we draw? We may draw this voltage. Let me call this V2 prime. Okay, this is also called the secondary voltage referred to the primary side. How much will be V2 prime? That will be V2 multiplied by N1 by N2. N1 by N2 is known, so we can calculate how much is V2 prime. So maybe that is here. Okay, scaled version of V2. This is V2 prime. Okay, next what else can we draw? We can draw this current I2 prime. Okay, note that I2 is leaving a dot and I2 prime is entering a dot. Yeah, I have missed very important things, these plus minus symbols for these voltages. Okay, so I'm assuming this as the polarity of the voltage, reference polarity, plus minus, and here also plus minus. Both the pluses for V2 prime as well as V2 are towards the respective dots. Okay, so that's why V2 prime is V2 multiplied by the turns ratio. So now similarly, I2 prime will be how much? That will be I2 multiplied by N2 by N1. How can I draw that? So that will be also a scaled version of I2, maybe here. Suppose this is I2 prime. Okay, before I proceed, let me tell one thing, that this phasor diagram will become very ugly and very complicated soon. Okay, and when this is completed, then after that it may be difficult to know or to figure out how different phasors or how different quantities are found. So therefore, please pay attention while I am developing this diagram gradually, because once it is completed, then it will be it will be more complicated, and then it will be difficult to figure out. So please mind each and every steps that I am going through. Okay, so now I know I2 prime and V2 prime. What next? What can I get next? Next, I can get the voltage drop across R2 prime and X2 prime. This resistance. Oh, sorry, I should write this as X and this as R. Okay, please point out all such mistakes that I am doing. Okay. So now how much is the voltage drop across R2 prime? So that voltage drop will be in the same direction as I2 prime, okay? So, but a small quantity, so that may be like this, parallel to I2 prime. So this will be I2 prime R2 prime. Let me draw this phasor starting from the tip of V2 prime here. So that so let me draw it from here. This is parallel to this I2 prime R2 prime. Okay. Next, how much is the voltage drop across X2 prime? That will be perpendicular to the current I2 prime. Okay. So that will be in this direction. You may also draw from here, from the origin, I mean like this. Okay. But yeah. So this will be, let me make it little bigger. So this is our I2 prime X2 prime. This is basically the voltage drop if I, from this point to this point. If I call this as A and B, so this is, then this phasor is the voltage VAB. Now if I add VAB with V2 prime, what do I get? I will get the voltage from A to C. Okay, so this will be okay, this is the voltage VAC. Okay, let me make it cleaner. Okay, so next what can we get once we know the voltage VAC? Okay, so let me just give it okay, fine, whatever. So next what can we find? We can find IR0 and IXM. How much will be IR0? IR0 will be proportional to VAC, and it will be a small quantity, okay, in the same direction. So this is IR0. And how much will be IXM? That will be perpendicular to VAC, okay, and a small quantity because XM is large, like this. This is IXM. Okay, fine. Okay, so this actually proves that no student is attending the class. So anyway, I have to continue because IXM must lag the voltage VAC. I have drawn it leading. I have done it intentionally, but all other mistakes were not intentional. So if you don't point out, I may have some mistakes unintentionally. IXM. Okay, so now if I add these two, this will give me the current that flows here, call it I0. Okay, so this is I0. Now I know I0. What else I know? I know I2 prime. Okay, if I know these two, what can I get? I can get this current, I1. I1 is the sum of these two, I0 and I2 prime. So, although I have drawn I0 quite large, actually it will be a very small quantity compared to I2 prime. Here I have drawn quite large, but still let me add these two. If I add, I get this will be I1. Okay, so let me write. I mean, after finding I2, what did I find? okay, after I2 prime, I found the voltage drop across this, I mean, so VAB, that was I2 prime into R2 plus JX2. Okay, so let me put these J's here, here and here. Yeah. Okay. After VAB, what did I found? I found VAC, that was sum of V2 prime plus VAB. Okay, now once I know VAC prime, I found I0, that was VAC divided by the parallel combination of R0 and JXM. R0 parallel JXM. Okay, now once I know I0, then I found I1 as the sum of I0 and I2 prime. Okay, so then I1 is I0 plus I2 prime. Okay, now I know I prime. What next? What can I find? I can find the voltage drop across R1 and JX1. Okay, so how will that be? That will be in the same direction as I1, so this will be, say, I1 R1. Okay, let me draw this phasor starting from the tip of VAC. Okay, so from here, if I draw, it's as I told, it's going to be very ugly. Okay, so this is I1 R1, and similarly, I am drawing it larger. I1 X1 will be JX1 actually will be here. Okay, yeah. So yeah, I should also put a J here. Now, so this pink colored phasor is the voltage drop from, if I call it D, from D to A. Okay, so this voltage VDA is I1 multiplied by R1 plus JX1. Okay, now if I add VDA with voltage VAC, what will I get? I will get V1. Okay, so finally V1 will be VDA plus VAC. So that will be, which color can I use? Green. That will be this phasor, that is V1. Now, so okay, so we have drawn the diagram, but one thing you notice that I started from V2, which is unknown, which is not known a priori. Rather, V1 may be known, but I started from V2, and from that I found V1. Now, suppose I know V1 is something like V1 angle, say 0 degree, but here I find V1 like this. How can I arrange everything or rearrange all this diagram so that the V1 becomes equal to the given input voltage? I am still missing this plus minus signs. Okay, so what can I do next? What I will do is this: I will just rotate this diagram, okay, to make V1 at the desired angle, in this case at 0 degree, okay. So suppose now it is at 0 degree, I have rotated it. Then I can also scale it up or down, okay. so that the length of V1 becomes equal to the length of this voltage. I mean equal to the value of this voltage. And once these two are done, then this diagram represents the actual Phasor diagram, correct Phasor diagram of this transformer. Okay, so now this V1 represents the true input voltage according to the given input voltage, and this V2 is automatically decided from V1. V2, yeah. Okay, so this is one way of drawing the Phasor diagram of a transformer. So I'm quite sure that you do not have any question. Do you? Any doubt? Any question? No. Okay. So
No.
let me just tell you that this can be done in many different ways. If you go through possibly 10 different books, you will see 10 different conventions and 10 different types of equivalent circuits. But the point is, once you understand it, you can do it in different ways. Okay, so maybe I show you one more way of doing it. Now what I will do, say I take this diagram, but say I draw this equivalent circuit in a different way. So what I will do, let me so you noticed that I have erased the R2 and X2 that were here. Now what I am going to do, I am going to bring this ideal transformer here and connect it directly. Okay. So now the R2 and X2 that were here, that is missing, R2 prime, X2 prime. What I am going to do, I am going to put here some R2 and X2 here. This is JX2. Okay, this is also equivalent to the previous circuit. Okay, when will it be equal? It will be equal if this R2 prime and this R2, they are related as R2 equal to R2 prime multiplied by, can anyone tell me what should it be? N2 by N1 whole square. Similarly, X2 prime, X2 will be X2 prime N2 by N1 whole square. Okay, so then this diagram is exact, I mean this is also equivalent to the previous diagram, previous circuit. Okay, now let us draw the equivalent circuit for this, let us draw the Phasor diagram for this circuit, this equivalent circuit. Okay, so here here is the actual transformer or practical transformer inside the yellow box. Now, once again, where can we start our Phasor diagram from? Should we start from the input voltage? That may be again difficult. It may be easier to start from the output voltage or secondary voltage. Okay, so before that, now let me put some more notations. So this voltage here is not same as V2 prime. So let me call it this is not same as V2. So let me call it E2, which is this voltage. And similarly, let me call here the voltage as E1 plus minus. Okay, this current is I2. Okay, and yeah, all other quantities we will find out as we proceed. So let us once again start from V2 as the reference. Let me make some space. Okay, so I start from V2. Now once I know V2, what can I draw next? Can anyone suggest? All impedances are known. All the impedances everywhere are known. So I have taken V2 as my reference. So immediately next, which phasor can I draw?
I2. E2.
E2, but before
I2.
E2 I cannot draw. Before that I need something else. Before E2 I need the current I2. Okay, so let me draw I2 first. Okay, suppose this is I2. Why can I draw I2 directly from V2? Because I2 is just V2 by Z. And Z is known. This angle is theta. Okay, acha. Now once I know I2, then I can draw I2. Okay, so for that, starting from the tip of V2, let me draw a phasor in the direction parallel to I2, representing the voltage drop I2R2. That is the voltage drop across this resistance. And perpendicular to it is the voltage drop I2JX2. Okay, although I am drawing it quite large, practically this will be very small, maybe at max about 5% of V2. But here for clarity I am drawing it larger. Okay, so now if I add V2 and these two voltage drops, what will I get? I get E2. Okay, next what can I draw once I know E2? Okay, I can draw E1. E1 will be just a scaled version of E2. Okay, so E1 will be say what did I take previously? I took primary voltage to be larger than secondary voltage. So if I follow the same convention, so here again let the primary voltage be larger. So this will be U1 in the same direction as E2 but larger depending on the ratio of N1 and N2. Now once I know E1, next what can I do? Okay, so this E1 is same as the voltage VAC. Okay, so here you notice VAC is same as E1. Now I can draw these two currents, IR0 and IXM. Okay, so so IR0 will be E1 divided by R0. So suppose this is, let me just draw with a slight gap. This is parallel. Okay, so this is IR0. So IR0 is E1 by R0 and IXM, that will be E1 by JXM, that will be lagging downwards. Let this be IXM. Now if I add these two, I will get, I have drawn it with a small gap to make it clear. Actually the origins should coincide. yeah, so now I add this to, okay, suppose this is the current I0, this current I0 here. Okay, now once I know I0, then what can I do? I can get the voltage drop across R1 and X1 and then add this voltage drop with E1 to get voltage V1. Okay, so suppose, before that, so this current is I2. Okay, so this, let me call this current as I2 prime. I2 prime will be I2 multiplied by N2 by N1. So let me write here, I2 prime is I2 N2 by N1. Okay, so that should be, what was my convention? Is N1 by N2 larger or smaller? Yeah. Oh, so voltage is larger, that means current should be smaller. Okay, so let me use a different color. Suppose this is I2 prime. Now you add this to I2 prime and I0. Okay, I0 should be much smaller compared to I2 prime, but okay, in my diagram they are almost of same size. So if you add them, this will be the resultant. Okay, so this is I1. So this is I1. Now you add I1 R1. This was E1. So you add I1 R1. That is a voltage drop in the same direction as I1. And then you add voltage drop across X1. So this is I1 JX1. Okay, now E1 plus these two drops all together will be this voltage V1. Okay, finally once again, what I have to do, I have to rotate it to make the angle of V1 according to the given phase angle for V1, in this case 0 degree. Okay, so I rotate it. I can also scale it up or down so that the magnitude or length of V1 is same as the value of V1, RMS value of V1. Once that is done, this diagram is complete. Okay.
Yes, sir.
Yeah. So I will stop here. Let this be the formal end of this course this time. Okay, if you have any question, I will try my best to answer. Any question?